The universe had a beginning. That much we know. Roughly 13.8 billion years ago, space, time, matter, and energy burst into existence in what we call the Big Bang. But if there was a beginning, does that mean there has to be an end? That question has haunted philosophers, scientists, and storytellers for centuries. Today, modern cosmology offers us several answers, each one stranger, darker, and more fascinating than the last. Let's explore what the final chapter of the cosmos might look like. The most widely accepted theory is the heat death, also called the Big Freeze. The name is misleading. It doesn't mean everything bursts into flame, but rather that energy becomes uselessly spread out. Right now, stars burn because of nuclear fusion, converting hydrogen into helium and releasing light and heat. But stars don't last forever. Over billions and trillions of years, stars exhaust their fuel. Red dwarfs flicker out, massive stars explode, and white dwarfs cool into black dwarfs. One by one, the lights of the universe go out. Entropy, the measure of disorder, always increases. Eventually, galaxies will stop forming new stars. Black holes will swallow what's left, but even they won't last forever. According to Stephen Hawking, black holes radiate energy slowly until they evaporate. After unimaginable lengths of time, the universe becomes a vast, cold expanse filled with faint radiation and subatomic particles scattered across unimaginable distances. This is the heat death, not an explosion, not a bang, but a whisper. A universe so evenly spread out that nothing meaningful can ever happen again. No energy gradients, no motion, no life, just eternal stillness. But what if the universe doesn't keep expanding forever? Another scenario is the Big Crunch. Imagine the universe like a balloon expanding after being blown up. Right now, that balloon is still inflating. Galaxies are racing apart from one another, carried by the expansion of space itself. But what if gravity eventually overpowers that expansion? If the universe doesn't have enough dark energy to keep driving it outward, then at some point the expansion would slow, stop, and reverse. Galaxies would begin falling back together, stars and planets would collide, temperatures would rise as matter compressed. Eventually, everything would collapse into an unimaginably dense, hot state, a mirror of the Big Bang, but in reverse. This would be the Big Crunch. Some theorists suggest it might even spark another Big Bang, creating a cyclical universe where expansion and contraction repeat endlessly, birth following death in a never-ending loop. Then there's the most terrifying possibility, the Big Rip. Right now, the expansion of the universe isn't just continuing, it's accelerating, driven by a mysterious force we call dark energy. If that acceleration continues unchecked, it could eventually overcome all other forces. First, distant galaxies would slip beyond our view as space expanded faster than light can travel. Then, galaxies themselves would tear apart, stars would drift away from each other, planets would be ripped from their orbits. And if it continues far enough, even atoms would be torn apart, ripped into subatomic particles. The Big Rip is cosmic annihilation at every scale, a universe stretched until there's nothing left but fragments of fragments. As if those options weren't grim enough, there are other possibilities too. Quantum physics allows for a phenomenon called vacuum decay. Right now, the universe exists in what we think is a stable vacuum state. But if it's only metastable, it could collapse to a lower energy state at any moment. If that happened, a bubble of altered physics would expand at the speed of light, rewriting the laws of reality instantly. No warning, no survival, no escape. Others imagine multiverse scenarios where our universe might simply fade, collapse, or rip apart, while countless others continue. In this view, our universe's end is not the end of everything, just the closing of one chapter in an infinite library. So why talk about the end at all? For one, it helps scientists understand how the universe works today. The fate of the cosmos depends on factors we're still measuring: the strength of dark energy, the density of matter, and the behavior of space-time itself. Each new observation brings us closer to knowing which ending is most likely. But these theories also matter because they reveal our place in the story. The universe is vast, ancient, and powerful, yet not eternal. Its future is written into its physics, just as surely as its past is written in the stars. The end of the universe might come as a slow fade into cold darkness, a fiery collapse, a catastrophic rip, or something beyond our imagination. Heat death, big crunch, big rip, vacuum decay. Each one is a cosmic finale unlike anything we've experienced. But here's the strange comfort. All of these scenarios unfold on timescales so immense that they dwarf human history. We will never see them play out. Yet thinking about them connects us to the vastness of existence. It reminds us how fragile our brief moment really is. The end of the universe is inevitable. But until then, the story is still being written. By galaxies, by stars, and by us. So what do you think? Will the universe die in silence, collapse in fire, or rip itself apart? Comment, like, and subscribe for more deep dives into mysteries of science and the cosmos.